Hello and good morning. Let's take a look here. Let's review a little bit here. What is a polygon? Well, a polygon is a closed figure, and no curves. Regular hexagon. A hexagon has 6 sides, but regular means all the sides are equal. So mark these equal, and all the angles are equal. So here I want the interior angle sum, the total. So that's n minus 2 times 180. And in this case, there's 6 sides, so put 6 minus 2. So that's going to be 4 triangles. Let's see what that is. So 4 times 180 is going to be 720. So all of these interior angles add up to 720 degrees. And because it's regular, number 2, you can find one interior angle. So one of these, you would take 720 and you would divide by 6. So one angle is 120 degrees. So let's see what that is. If this angle is 120 degrees, how much is the exterior angle right here? Well, every line is 180, so 180 minus 120 would give you 60 degrees. Because it has to equal 180. It has to be supplementary. Find the exterior angle sum. All of the exterior angles, no matter how many sides it has, you add them all up, 60 times 6, it's going to be 360 degrees, always for the exterior angles from before. Now let's take a look at today's work then. Put away your bell work. Today we're going into 6.2, and this is as far as we're going to go until we get back from break. So look up here, copy down everything you see up here, and what we're dealing with is properties of kites and trapezoids. So let's start off with a kite. So you know how a kite looks. It looks like this. And this is called a diamond kite. And this side is equal to this side. And I'm just going to make up a number here. And this side is equal to that side. So two pairs of congruent sides. The angles on the arms, these angles right here, left and right, are equal. Not these, but those are. And the diagonals come in at 90 degrees. Perpendicular diagonals. So all of these are 90 degrees. And those are the three properties of a kite. The next one is a trapezoid. A trapezoid has one pair of parallel sides. So draw two lines, make them parallel. Those are called your bases. These are called your legs here. So this would be a trapezoid here. Okay? The area of a trapezoid is 1/2 the height. And the height goes from base to base. Write that down. That's your height. So you add up the bases, you multiply the height, and you divide by 2. Alright, the next one is an isosceles trapezoid. An isosceles trapezoid has the legs equal. The bases are still parallel, but this leg is equal to that leg. So again, I'm just going to make up a number. And the diagonals are congruent for an isosceles trapezoid. So this diagonal is equal to that one. Okay, the legs are congruent, and the diagonals are equal. All right, so let's talk about this. Draw this diagram here. Well, you can see it's an isosceles trapezoid because the legs are equal. And this is BD, it's a diagonal. And this is AC, it's a diagonal. And for an isosceles trapezoid, they're equal. So put 9x minus 3 is equal to 7x plus 5. It only works for an isosceles trapezoid. Now go ahead and work that. Yes, you would subtract 7x and get 2x. And then you would move the 3 over here, and that would become a plus, so that would be 8. And so x would be equal to 4. Make sure you get 4. And if they want to know the diagonal, you'd have to plug it into either one of these. Okay? So 7 times 4 is 28, and 5 makes 33. So each of these diagonals is 33. Draw example 2. Well, it's a kite, and we know that the diagonals come in at 90 degrees. So put a box right there. Every triangle adds up to 180 by the triangle sum theorem. So take 180 minus 30 minus that 90, and whatever you get will be your answer. That's 120, so that would be 60 degrees. This one over here is 90. Remember, these are equal. So if that's 30 degrees, this one is 30 degrees. Okay? If the whole thing is equal to the whole thing, then this upper piece right here is equal to that upper piece there. And one more. There's something called the Mid-Segment Theorem. You see how this segment is in the middle of this side, and it's in the middle of that side? So the Mid-Segment Theorem says that the mid-segment, which is what that is equal to half of the sum of the two bases. So you would add these up and divide by 2. So let's do that real quick. 55 plus 33 equals that, divide by 2, and I get 44. So the mid-segment is 44 inches. And that's how you do that. That's called the mid-segment theorem. Here's your work for today. Go ahead and work quietly. If you get stuck or you're not sure, please ask. Let's turn our attention now to MCR. All right, so for MCR, you have to factor. Let's take a look here. Well, this one right here is 2 terms, so I'm seeing if they have anything in common that I can take out. There's nothing that I can take out. Okay, so what I'm going to do is do the difference of 2 squares. So this is going to be 2x and 5. So it's going to be 2x plus 5 and 2x minus 5. And that's how you do the difference of 2 squares. This one has 4 terms, number 2. So you want to see if they all have x's or something in common. And I don't think they do. So we're going to go here and we're going to take out a 3 and an x squared. So if I take the 3 and 2 of those, I'm left with 1. And I think I have an 8 right here because 3 times 8 is 24. That's a negative, so you got to pull out a negative. And I think it's going to be 4. So 4 times 8, it should be the same thing, remember? X minus 8. So now that you have the same thing, your final answer on your test over the weekend is going to be 3x squared minus 4 times this one. All right, the last one here, it's 3 terms. Your first one's a negative. You have to pull out a negative, okay? I guess you could put this one first. So you're looking to see what they all have in common. I think they all have a 5, and they all have 3 x's. So this one is just purely the greatest common factor here. So you want to put a 3, an x squared, a plus, a 5x, and then this one right here is going to be a plus 3. And actually it's got to be a minus 3 because a negative times a negative would make positive. Okay, so the signs change right here when you take a negative out. This one changes, this one changes, and that one should change as well. And there it is. Today you have a worksheet, and the worksheet looks like this. Okay, so if you can't download it on Canvas, you can just copy it right here. Make sure you label it. Have a good morning, and I'll see you in class.